Hello, my name is Jeffrey, and this is my video lab report for Physics 2212, lab number 3. Introduction. The purpose of this lab is to determine and simulate the properties of a magnetic field generated by a bar magnet, and to verify that a bar magnet behaves like a magnetic dipole. The physics principles used in this lab are mainly the equations derived from the Biot-Savart law, particularly the magnetic field of a dipole, the magnetic field of a dipole on the parallel axis, and the magnetic field of a dipole on the perpendicular axis. In addition, I also used the equations for the magnitude of a bar magnet, which is defined as k times r to the power of n. This can also be written in terms of natural logs, as shown in the bottom left-hand side. To model the behavior of the bar magnet, I used magnetic field lines from a magnetic dipole, as shown to the bottom right-hand corner. The main result was that in the magnetic field of the bar magnet equation, I found that the exponent n equals -3. I also found that the mu of the bar magnet was 55.3 units, and then I proved that the bar magnet acted like it matched the behavior modeled by the magnetic dipole equation. For the experiment, the system was a bar magnet in the Earth, and the surroundings were the phone magnetometer. The initial condition was the magnetometer was at a set position away from the bar magnet for each trial. And the assumptions were that there was proper alignment with the magnetic north pole for each trial, there were no outside effects ruining measurements, nearby electronics, and so on, and that the magnetic field constant K was constant. This description of the lab was that first we downloaded the magnetometer app on a phone, then we verified Earth's magnetic field would not impact results by careful phone alignment. We then used tape and mirror sticks to determine the magnetometer's location within the phone, and then we measured the magnetic field along the x-axis from set locations along magnetic east-west, and record our results in a spreadsheet with repeated trials. For the second part of the physical experiment, we found the perpendicular distance where the net magnetic field was 100 microteslas. We then moved the phone in the perpendicular direction from this measurement such that the phone and the bar magnet were at a 45-degree diagonal. And then we found the magnetic field in this position at the x, y, and z directions, and then corrected for the influence of the Earth's magnetic field in the y direction. So for observations and conclusions, this spreadsheet screenshot shows all the measurements that we took. And based upon the graph formed by the data, n equals -3 in the formula shown below. For the computational model, here you can see all my code. First, I defined my mu naught over 4 pi. I created the magnet and set it at the origin, and then made a function for the magnetic field based upon the equation I showed earlier, and then did some generations to find the ops locations, and then the magnetic field at those ops locations. Here you can see the average dperp from the experiment was also put into code in order to generate a simulation of the experiment we performed in the lab, and the results are shown to the right-hand side. Behavior of a bar magnet was found to match that of a magnetic dipole. There are slightly different magnetic fields, however, between the experiment and the computational model, and there are a few causes for why this could be the case. First, there's no effect from nearby electrons, was the main assumption that we had to make. And then we also had to assume that the Earth's magnetic field would probably accounted for, that there are accurate readings from the phone's magnetometer, but these are all assumptions, and therefore, if one of these things were off, that could be a possible source of error. So, what if I hadn't oriented the experiment for my experiment for the magnetic north, and I laid out the meter stick at some intermediate angle? Well, in that case, the Earth's magnetic field would have interfered with the magnetic field from the bar magnet in unpredictable ways, and then this would lead to readings that don't necessarily reflect the influence of just the bar magnet. And if I were to stick two identical magnets together end to end and run the experiment again, the magnetic field at any location would be in the same direction as with only one magnet. And as for the magnitude, it would be twice as strong on the axes, and it had varying results on the off-axis directions.